Lord Buddha preached that the human mind is unable to understand the universe, but man has been trying to find its secrets since the past. As a result, we have gained some knowledge about the universe today. That knowledge has been so enlightened that the solar system can even send spacecraft to other planets and land people on Earth. Since the landing on Satimet happened more than 52 years ago, many of those who were there said that these Vedu planets must have been inhabited. But at this time, due to the efforts of people like Elon Musk and Jeff Bezos, the new Cold War between America and China and the space race has started again, so the number of people who are interested in areas such as outer space and astronomy has increased again. So I invite you to wait until the last moment of this precious video. Number 1. What really happens if you fall into a black hole? A black hole is something that baffles ordinary people interested in the universe and even highly educated people. Although it was first thought about by Einstein's relativity equation, it was only recently that black holes were actually confirmed. Like many other things, black holes in films started to be created, but at the same time, a lot of wrong information started spreading. Today we are trying to correct some of them with the latest knowledge. A black hole is an object that pushes a huge mass into a very small area. Although this is called a hole in common practice, it is considered as a very small collection of twigs. Due to the immense mass of a black hole and its condensing into a very small space, both the concepts of space and time behave in a strange way even near it. The extra gravity experienced by a black hole is actually due to the curvature of space and time. Any black hole has an event horizon or a limit called the event horizon. This is the speed at which it needs to escape from gravity. This limit exceeds the speed of light. There is no escape for an object that enters this limit, or at least for light photons. But depending on the mass of the black hole, it can be a completely different experience. This is especially true for a small black hole. The event horizon of a black hole with a relatively small mass of several times that of our Sun is located very close to the black hole, about 20 kilometers. Because of this, even short, the difference in gravity is very high. When you get close to the event horizon of a black hole like this, you will be pulled like a noodle because the gravity you feel on your legs is much higher than the gravity you feel on your head. Scientists call this spaghettification. Therefore, if you approach a small black hole for a long time, your destruction will definitely happen. If you want to get close to a black hole, the most suitable is a massive black hole. Often located at the center of galaxies, these can have masses ranging from a few million to billions of times that of the Sun. So the event horizon is as big as our solar system. Because its gravity doesn't change over short distances, you can enter it relatively unscathed. Falling into a black hole is very different from falling into a bubble that we think of all at once because the behavior of space and time is distorted in the vicinity of a black hole. As we get closer to the black hole, the time we perceive and the time experienced by an outside observer change significantly. As a result of this, an outside observer can see that anything approaching the black hole slows down. Near the event horizon, it stops completely and the brightness gradually decreases and disappears. Not only that, but what happens when you enter the black hole is more strange than you think. At first, you see a dark hole in the middle of many stars. Because of the curvature of space, little by little, you will see that the whole sky is confined in a small circle. Number 2, there really is no such thing as gravity. Albert Einstein's theory of relativity is the most basic theory used by scientists who are searching for the secrets of the universe. Although this is a very complicated matter, there are several conclusions that can be drawn from it. One is that both space and time are relative. If we put it in a different way of understanding, then both time and space are different according to the measurement frameworks. The basic principle that determines the movement of all planets and larger objects in the universe is their mass. Due to the accumulation of large amounts of matter in a certain area, both space and time undergo a pull or curvature. This curvature of space and time around an object of great mass is what we actually see and experience as gravity. Otherwise, there is no great strange force called gravity. The force we experience as gravity is just a result of the force we experience when we try to move straight through curved space-time. This ability to bend space and time is called gravity. You may have heard that any object remains at rest or moves at a uniform speed in a straight line when no external force is applied. But the most important story that is being forgotten is that when the space is curved, the so-called straight line becomes curved. So when an object with high mass is near, any object near it moves in a straight line through the existing space. A gravitational pull can only be seen by an outside observer. Let's understand this with a simple example. Just imagine that you and another person are trying to go to the North Pole from the equator in a straight line. Imagine that there is a distance of 100 kilometers between you two at the equator. The gap is closing, isn't it? If you grow up, someone who is watching can see that this is happening because of some force pulling you two together, but you two are getting closer as a result of trying to move straight along the curve. When I heard this, I thought it was absurd, but many things that we actually see are a direct result of it. If we think about a force called gravity, it can be seen experimentally that the light photons that have no mass, however, are clearly curved near large objects. This is because light also travels in a straight line through space. This can be properly explained through the theory of general relativity. It has always been clear that general relativity is accurate. It is more accurate to understand that gravity is purely an illusion and the result of trying to move straight through curved space. Number 3, matter and dark energy general relativity is a very accurate law to describe the motion of most massive celestial bodies, including planets and stars. Similarly, quantum laws describe the motion of small objects very accurately. The impossibility to formulate a law that fits both the quantities of these objects is a big puzzle that exists in physics even today. The electromagnetic force, which is very important on a scale as small as an atom, the weak nuclear force and the photonuclear force, and gravity, which is important on a larger scale, have not yet been able to be explained with a single law. Dark matter and dark energy, or dark matter and dark energy, is also a strange behavior that can only be seen at a higher level on another scale. We are trying to explain this from what we know. Just think of the difference in scale between an atom and a planet, and there is a similar difference in scale between a planet and a massive system like a cluster of galaxies. If we look at it in another way, in other words, if we consider that an atom is as big as a planet, we are talking about huge objects that are the size of the planet now. There is clear evidence that there is more gravity than we can normally detect in such large objects. As mentioned earlier, gravity is considered to be the amount by which space and time are curved. For objects as large as a galaxy or a cluster of galaxies spanning hundreds of thousands of light years, this curvature is clearly greater than would be possible due to their mass. Dark matter is only a certain idea to be used to understand. We still don't know if it is matter or not. If we only consider that space and time can be curved or that gravity can arise from matter, then we have to consider it as matter. Otherwise, we really only see its gravity-related characteristics. This story can be understood simply like this. Think of a parked car. We can imagine how much the bow should be pressed according to the weight of the car. According to that, there is some weight. There is some conclusion or some inference that there is a strange matter that we do not know about such huge objects like galaxy clusters, and this map is called dark matter. It cannot be successfully detected on a scale like planets or stars. Dark energy is another thing like this. When we consider supermassive space systems that are larger than galaxy clusters or superclusters, a clear result of their existing gravity is that the universe must contract rapidly. Because if we look at existing matter only in terms of size and gravity, they must be close to each other. But what is very clear experimentally is the fact that our universe is expanding rapidly, and not only that, the speed at which the universe is expanding is increasing more and more. So we use the concept of dark energy to explain that. According to it, there is a strange and undetectable energy in all objects that we cannot see. But that gravity surpasses dark energy, etc., and comes forward only in large objects on another scale, like galaxy superclusters and the entire universe. If we go back to the example of the car we talked about earlier, dark energy is like having unimaginable energy in the car. If we know the engine power of the car, we can usually imagine the speed of the car. But we see that it runs several times faster than that. So we think that apart from the engine we know, some other system that provides energy like a nitrous system will be installed together. The concept of dark energy is also explained here. Take a certain trick that we all use. So in the end, even though these are a little deep concept, if you are someone who is interested in the universe, we believe that these videos will be very interesting. Stay connected with us to know more about things. Be sure to share this video with your friends. And don't forget to subscribe to us by pressing the red subscribe button below. Also, press the bell icon and then you will get a notification when we post a video.